I think I am live, but I don't know if someone will moderate.
अरे एक ही रखो ना speaking. Only me, only me. Good afternoon, everyone. So I welcome you back to the 3-day national webinar on lithium-ion batteries and beyond, a perspective for future energy storage need. So we are resuming our day 1, session 1, talk 2. We have our invited lecture by Mr. Nikhilesh Mishra, founder and CTO at GreenTech. At the end of the lecture, we will have some questions. So put up your questions in the comment section. Now I request Professor Partha Saha to give a brief introduction about Mr. Nikhilesh Mishra.
Namaskar. A very good afternoon to all. I have the pleasure to introduce you our next speaker, Mr. Nikhilesh Mishra. Mr. Nikhilesh Mishra is co-founder and CTO of GreenTech, an innovative EV battery startup that was incubated at the IIT Madras Research Park, motivated by the urgent need to transition to sustainable mobility. He has led the development of a range of electric vehicles, lithium-ion batteries, tailored to a spectrum of applications from two-wheelers to cars, light trucks, and farm tractors. GreenTech's competitive advantage stems from high-performance proprietary designs of battery packs and their BMS systems. Since the start of their commercial operations, GreenTech already served a number of highly reputed brands in India and overseas. Over to Mr. Nikhilesh Mishra.
Thank you, Professor. I hope I'm audible. Let me share my screen. Okay. I think it's uploading. Yeah, I see it there. Okay, I hope you all can see this. If not, put in the message. Otherwise, I assume that it's visible and I will proceed. There are not too many slides and not a lot of text there. So I will actually like to talk more, and even more than that, I will like you all to ask question if any question you have. Okay. My discussion will be mostly towards the BMS, although not restricted to, because the safety of a battery is not limited by BMS. In fact, most of the fire incidents you are hearing nowadays are many a times manufacturing defect also. So don't assume that it is more or less all the fault of the BMS. Is not. But BMS obviously is one of the very important part of that. So we will be talking about the safety aspect. We will be talking about the BMS. Now, the first and most important thing, and it may sound very uh, maybe scary or maybe very counterintuitive, but a standard 21700 cell, that's a 5-layer cell in general, contains equivalent energy of around 3 hand grenades. Now, there are big hand grenades and a small one, so there is one comparison between the two. Grenade can very easily flat a big building or probably a big apartment also. Now imagine three of them, and that much energy is stored in a single cell. So then question comes that why not there is a blast and like that, right? Because the hand grenade can release its energy in probably few millisecond time. The battery cannot. It's not possible, and that is the reason that it doesn't blast like that. but it can release all its energy within few second time. That is possible, especially when you have a very high voltage in the cell. You have charged it much more than what it can, and then there is a internal sort or even external sort. When it goes in thermal runaway, it doesn't take more than few second time. But still understand that still that is few second versus I'm talking millisecond. That is the difference, that a hand grenade can bring down a building, a cell cannot. But the amount of energy remains same. That's why the damage that it can create over the time can be same. And now imagine a two-wheeler battery which will have probably something like 70 to 100 number of those cells on an average, a small two-wheeler battery. So you can imagine the amount of energy that you are carrying inside that. And that's why it is very important to have a safe battery. So what we'll be talking about is the history of BMS. First, we need to understand why we need a BMS or how it all started. It's not only about the safety also. In fact, the reason BMS started was not even safety. I'll come to that part. Then we will talk about what purpose it is serving today, what all the BMS is doing today. We will try to understand the difference between the analog protection board, which is a basic BMS used in more or less all the two-wheelers out there right now. Not all, but majority of them. I will not take name, but you will understand what I'm talking about. Most of the ones which are catching fire and all, they are not exactly using a BMS. They are using something called a protection board, and it's an analog system. So we'll try to understand the difference between that one and the digital BMS, which is worthy of being called a BMS, right? Then we will try to understand the safety aspect of a bad BMS design. What type of things can go wrong? And we will talk about the way forward from there. So let's try to let's understand that why we need a BMS, right? Because the first question comes in that the BMS is more or less only used in a lithium-ion battery. It's never used in a lead-acid battery. Almost. There are some cases, but very rare. So the question comes that why we need a BMS in a lithium-ion battery, but we don't need it in a lead-acid battery, right? The primary reason actually is cell balancing. Because lead acid battery, you all might remember, if you full charge it or when it reaches near the full charge, you will hear a bubbling sound. Maybe not in the SMF as much as in the flooded lead acid, the traditional lead acid battery with water and acid filled inside that. When you charge that battery, and especially when it reaches its end of charge, you will hear a bubbling sound. And if you open, you will actually see it bubbling, the water inside. So when that happens and that bubbling is happening, and you will see that the battery gets hot, that those lead acid battery. What exactly is happening is when the battery is full charge and you keep on supplying a little amount of current, not a lot, but that's what is called a trickle charge, a small amount of current, the battery can actually release that energy. So the extra current that you are putting multiplied by the voltage, that is the energy, right? So you are putting some energy. By bubbling, and heating, the battery can get rid of that extra energy and the battery will not overcharge. Now that doesn't mean that it will never overcharge. If you apply a lot of current, it will overcharge. But if you apply a very small current, something in the range of C by 100, so 100 Ah battery, if you try to charge at 1 ampere, the voltage will actually not increase. It will just waste that 1 ampere into 12 volts, so 12 watt worth of power. It will keep on getting rid by heat and bubbling, etc. That you can't do in a lithium-ion battery. That is the problem. In lithium-ion battery, if you keep on supplying a very little amount of current, over the time it will accumulate and battery voltage will go high, and then it will go in thermal runaway. That is the basic problem. And that is why when you have a little bit of unbalance between the cell, which always will be there, the lead acid can get rid of that. When you keep on charging slowly at the end of charge, the one cell that is at a relatively higher voltage will keep on bubbling and losing its energy, while the one that is at a little lower voltage will catch up, right? So you don't need to do anything. All you need to do is after reaching almost full charge, you keep on charging at a C by 100 rate for another 1 hour, 2 hours, something, and the battery will balance itself. But if you look into the lithium ion, it's not going to happen. So you need to find a way to discharge the one cell or any cell which is more than other cell voltages, right? That one you have to discharge, and that is what is a balancing. And you need a balancing, and that's why a BMS started. It doesn't actually started from the safety point of view. Not that it was not needed, but because initially the number of battery in the usage was very small, so number of or the probability of fire was also very small. So it was not the primary concern. The primary concern was that cells were getting unbalanced, and because of that, there was a safety problem coming from that, right? So that is the reason of starting. So in fact, the first generation of BMS for a lithium-ion battery was basically just a cell balancer, not even installed in the battery actually. It was a separate device which you will connect it to the battery and balance once a month or once in 2 months, something like that. Then people started observing that okay, that is not enough. So they started installing that circuitry, which is basically a balancing circuitry on the on the battery itself. When that was installed, people thought that okay, and that was an analog system, basically just comparators with some MOSFET and resistor, etc. So then people started thinking that okay, what if we do it in a digital way instead of doing it with an analog system? So they made a digital balancer. After that, they thought that okay, now that this is a digital system, there is a microcontroller, we can actually do a lot more. So people started adding feature, and then what we call a BMS today was born out of that. So that is the history, and it's not very old. It only I'm talking something like around 20 years ago or 25 years ago, maybe not even 25 years. Something that type of timeline I'm talking when people were experimenting with this type of thing. And then the evolution has happened for the BMS, and then what you are seeing as a BMS today was there. So now let's talk about what all the BMS is doing. Okay. So first is safety. The and that is the most important one, obviously, but it's not limited to that. So when we talk about safety, the three most important thing is the voltage, current, and temperature. Right? You need to have a way to know the cell voltages and pack voltage and do something. Basically, that do something is generally either disconnect the battery, which actually is not the right way. In a serious application, the BMS never disconnects the battery actually. The BMS requests the charger or the load to disconnect. The BMS itself doesn't disconnect. That's the norm. But at the worst case scenario, if nothing happens and the load and the charger is not really listening to you, you can disconnect. So BMS will always have a way to disconnect the battery, always. So that is one thing, the voltage. If it goes outside the thresholds that you seem acceptable, if it goes out of that, you will disconnect. That is one. Second is current. If current is more than what you define acceptable, either in charging direction or discharging direction, again you will disconnect. The third is the temperature. If you see the cell temperature is more or less than your acceptable limit, again you can either ask the device to disconnect current or you can disconnect. These are the three most obvious and most important one, and that's where it all started. But now there are more features. For example, you will almost always have a fuse on the line. You will have cell balancing. Like I said, if you don't do cell balancing, the cells will go in high voltage and low voltage, and this will create a problem. So you will have a method of cell balancing. Now, let's say you cannot measure the cell voltage because the wire is broken and you are reading some wrong voltage. It's possible because when cell sensing wire is broken, it can send you a floating voltage. And you might consider that okay, battery is still okay, but it might not be okay, and it might be giving you a wrong voltage. So present generation BMS, especially the good one, they will have a method of knowing if the cell voltage sensing wire itself is broken. It can do that. The present generation smart BMS, not all, very good quality one, really good quality one, and we do that at Green Tech. If any of the wire is loose, the BMS knows that, and it's very important because if you have a loose wire, the contact will not be great, right? And then because of that loose contact, it will start heating or it can even arc and it can catch fire. It's possible. So really good quality BMS, they will have a feature of knowing if any wire or any bolt or any ring terminal is loose. It can do that. It's not like very easy, or it's not like at every point you will do it, but at the most important points you can add that feature and you can know that if something is wrong. Now, these are all safety, right? But safety is not the only thing that the BMS is doing today. The BMS is also adding lot of features which are not safety but very essential. For example, state estimation. Now, state estimation, there are multiple of that, but the most important and most common one that you always will hear is a state of charge. So basically, how much charge your battery is, which will help you understand that how much more you can drive your vehicle, or if it's a UPS, how many more hours it will operate, like that, right? So it's basically like your fuel gauge. But there are more states like a state of health, which basically tells you that how much your battery has degraded. There is a state of power, a state of energy, etc., etc. Then there will be data logging, because when you have a battery, you are using the battery. Over the time, you will like to connect it to the battery, talk to the microcontroller, and ask the history of that. What all has happened? What was the average temperature that battery was used for, or the voltage? There's a lot of things that you can log in that, and then you can find out, which will help you design better battery, ensure safety, etc. There will be power management. There are multiple things under that, but basically power management is that how you are charging, discharging, control of that, talking to a vehicle, talking to charger, talking to DC-DC converter, talking to the vehicle control unit, talking to a lot of things. So basically how you are managing your power when you are turning on, turning off, etc. Right? There could be non-safety related sensors, like three sensors we talked about, right? Voltage sensor, current sensor, and temperature. But there could be other sensors which are not exactly safety related or the battery safety related. It could be other safety related also. For example, you can have a crash sensor. If a vehicle has crashed and the battery can sense that there are crash sensors available, you can simply disconnect the battery in that case to protect the system, right? Because of crash, it's possible that there might be an internal damage and there can be a problem of current leakage, etc. So you can disconnect it. There could be see a measurement unit in a nice way, or if the road condition is good or bad, etc. Right? These are all added feature. You can have onboard data analytics. After logging all that data, you can run a lot of data analytics, and you will need powerful processors for that. The general BMS cannot do it. So there are actually different ways for that. We have some patents also in that right now. So there are ways to do data analytics on board to find different type of answers. Right? And then there is communication. I already talked about that. You can talk to the VCU, charger, motor controller. You can talk to the IoT if you have. You can send data out. You can have BLE. You can have wireless firmware update like a FOTA. You can have wired firmware update, debug communication. There's a lot of communication that you can do. So overall, if you look at all of this, you will see that the safety on the left is actually not even the majority of things now. The majority of things are actually features and communication, etc. Not to say that safety is not important, obviously it is. But the thing is, in today's generation, the BMS is not only a safety device. The BMS is a powerhouse of capability. There are a lot of things that we are doing today, and they all are important. No matter how great a battery BMS you have, if you don't know how much energy is left, you cannot really drive, right? You if you forget when you last charged and how many kilometers you have driven, which no one actually remembers, you will be in trouble. You will not know, and you will get stranded on the road. So in today's generation, a BMS is serving much more than balancing, which it started with, or the safety that it is generally considered for. Now let's talk about what is the difference between the analog protection board and the digital BMS. So you can see two images here, the one on the top and one on the bottom. The one on the top is a genuine, a proper BMS. Now this is one of our BMS. We have many of them. This is the BMS that we use for like a two-wheeler or a low power three-wheeler applications. This is a very simple one. If you use, you can see the number of components on that. The BMS that we use for a truck will be much bigger than that, something like 4 to 5 times bigger with at least 10 times more components on that. So the overall, but the basic comment concept remains same. Also, you can see if you compare between the top and bottom, you can see that the number of components that are on the top and the number of components on the bottom are very different. So what you see on the bottom is basically a analog protection board. Now, this primarily comes from China, although not limited to, but this is what is majorly being used in electric two-wheelers and electric three-wheelers in India today. And they are not safe. They are really not safe because there are not many feature in that. If you observe on that image, you can see there are lines of component, right? There's a big resistor on the top, and then there are some resistor capacitors, some small IC in a line. Those are basically individual line. If you have, let's say, a 16 channel BMS or 16 cell in series BMS, there will be 16 set of that. And what all that IC, that components that you are seeing, including the IC, is doing is only three things. It is doing a cell over voltage protection, a cell under voltage protection, and a cell balancing. That's all. There's nothing else being done. There can be a short circuit also, because you can see on top left there is something that is basically a shunt. So there is will be most likely a short circuit protection, but that's all. Over voltage, under voltage, a short circuit, and balancing. If you remember this slide, you can see all those features that are there. Even in the safety also, there are many more features. The most notable missing feature here is the temperature sensor. These protection boards don't have a temperature sensor at all. So if your battery is heating up for whatever reason, you will not know, you will not stop, and it can catch fire, and it is catching fire. A lot of those batteries are catching fire. But if you look at the top, there are many more features there. There are too many different components. You can see the number of connectors that are there is different. So there are a lot of different features there. Like I said, all these features on this slide, there is a microcontroller on this BMS. There will be a BMS IC which will measure the voltage, temperature, current. You can set values at what voltage you want to give a warning, at what voltage you want to give a fault. You can even have a latchable fault. If you are frequently doing a over voltage, the BMS will stop allowing you to do it again. It will go in a fault which will not clear automatically. It will only clear by going to a service center, and authorized service person can only clear that fault. So there are a lot of different features. Like I talked about, you will have a sensor for knowing if the voltage sensing wire is broken, or a sensor to know that the bolt is loose, etc. On the image itself, you can see there are these terminals are there on which you will tight your wire and the current will pass, right? If that is loose, the BMS will know. So though all those features are not in the protection board, and that is primary reason that these are not safe at all. So there are safety concerns. Like I said, temperature sensors are not available. Pack level thresholds not applicable, because these BMS, the bottom ones, are only working at cell level. There is nothing being calculated or acted upon at the pack level. Fuse are also not part of BMS, although if you want, you can put it externally. Although I have seen very frequently that there is no fuse in those battery, but that's a design or a decision. So ultimately, if you look at the percentage of features that are available in those protection board versus a digital proper BMS, the protection board is very much similar to actually not having a BMS at all. Only thing that it's very much similar to the first generation of BMS, which was more or less only doing the work of cell balancing, because there is only a cell over voltage and under voltage protection, and that also there is no redundancy, so it's very much possible that it will fail and you will be in trouble. That's why it's not recommended to use this type of protection board. Always use a proper BMS. Of course, there is a price difference between two, but it's not very high. The price difference will not be more than, I mean, like 15-20%, maybe not more than that. It's not like a huge difference in price, but it's definitely important from the design point of view. Designing the bottom one is very easy. Designing the top one is not. There are very few companies in India or actually worldwide who can design a proper BMS with all the safety features. That's why you will see a frequent use of the analog protection board, because making that is very easy, but it's not safe. So if we talk about the safety concerns of the bad BMS, like I said first, the temperature sensor is not there, which is a very big safety risk. There is no communication to the charger or the vehicle. That also is a safety risk, because let's say there is over voltage or under voltage, the BMS will simply cut off instead of requesting the charger or the vehicle to stop discharging or charging, right? The effect of that is, imagine you are driving on the road at let's say 60 kilometer per hour on the highway, let's say, and then suddenly the battery cuts off. You will lose power. You cannot do anything. You cannot immediately stop, because there are vehicles running behind you. They will run over you. You cannot immediately stop also. So it becomes very tricky, and it becomes very much of a safety risk. That's why it's not recommended to suddenly cut off. It's always recommended to that if you have to cut off in well advance, let's say 10 seconds, 15 seconds before that, you tell the vehicle that I have to cut off, you take action. Then vehicle will generally show on the dashboard that battery will cut off, or the vehicle will stop running in next 10 seconds. So you will get 10 or 15 seconds to slow down, take a left, get on the side of the road, and then stop, right? That's a safe way of doing it. But if you suddenly lose power, it becomes very big of a safety risk. So that's why I said initially that is generally not recommended to suddenly cut off the battery BMS, or the power from the BMS. You are always supposed to ask the battery, sorry, the vehicle and the charger to stop instead of you cutting off the BMS or the battery. These protection boards will not have multiple layer of safety. The proper BMS will have multiple layers. For example, to avoid over voltage in the battery or cell, on an average, the battery will have minimum 3 protection levels, and there could be even 4 or 5 protection level. For example, if I'm talking to the charger, I will ask the charger to give a certain amount of voltage only. That's first protection level, right? It will not give more than that. Second, there will be a proper a TVS diode which will behave like a short circuit if there is more voltage coming. Those things are not in a protection board. Third will be your BMS will have setting which will give a warning, or it can cut off also, right? So that is third. there are these three minimum. There could be more. The charger can itself have a TVS diode, and there can be more features, right? So all that will not be there. All those level of safety will not be there in the Chinese protection board. There is no way to know the cell behavior in a protection board because there is no microcontroller, right? So you cannot talk to the BMS. You cannot find out what exactly is the voltage. So debugging also becomes impossible in that case because there is no way to talk to the BMS. So there are a lot of safety concerns in these BMS. So you are hearing all these lithium-ion batteries catching fire, right? And the general perception has started to 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 be accepted is that the lithium-ion battery is supposed to catch fire. Actually, it's not, especially not at a small volume. Now, anything can go bad when you have, let's say, 10 million of two-wheelers running on the road. Definitely, something can happen. Petrol vehicles also catches fire, right? But at current volume, when we are talking about 1 lakh, 2 lakh vehicles being sold in a year, there should not be a single fire incident. But contrary to that, there are so many fire incidents happening, and that all is not because lithium ion battery is susceptible to fire. That is more or less always because those designs are poor, the manufacturing processes are poor, and the BMS are poor. If you do a proper BMS design, it will not catch fire. Now again, green tech, we have completed at least more than 2 to 3 million kilometers till now. Something like 20 lakh kilometer or more than that we should have completed till now. And more than a million hour of operation in the field. But we have never had a single fire incident. How is that possible? Because you do a proper design of the battery, you do a proper design of BMS. So it's possible to not have a fire. It's not a very big thing. It's just that you have to make right design decision and you have to do a good design. Now, future of the BMS, what all we see happening in the future. See, the safety side, there's not much that you can add in feature. What you will add is probably more layer of safety. Like I said just now, that right now there are 2 or 3 lakh two-wheelers or electric vehicles being sold in a year, and they should not catch fire. But when 10 lakh or 20 lakhs are being sold in a year, there will be a chance of fire. But that is not good, right? Because India is selling like 20 million two-wheeler in a year, 17 actually last year. So 17 to 20 million two-wheelers in a year, which means that there will be more than 10 to 20 fire incidents in a year if that type of volume starts being there, which is still not good. It should not happen, right? So you will have to increase your safety features even more. Mostly there will be more layer of safety, there will be more better sensors, better algorithms, etc. But more of the work in future in the BMS will be on the feature side. There will be more robust communication between the battery and the BMS. There will be better integration processes. There will be more feature inside the BMS, like I just said. Means we are having some features like if a service person is opening the battery is supposed to not have the voltage in that. But let's say someone forget to turn off the battery is on, and service person is opening that, right? That's a safety hazard. So you can have a feature in which if the battery gets open, the battery will automatically turn off. That is possible. We actually do that feature. Or let's say an unauthorized person is opening the battery can go in a lock mode, which will stop operating and it will not operate again. So there are a lot of different type of features that can be added. Then there will be features on or the advancement on the hardware side of the BMS. For example, there are a lot of discussions going on for a wireless BMS also now. Now, wireless BMS doesn't mean that everything will be wireless. It's more or less right now that the master to slave communication will be wireless. That is the first step people are doing, and there will be more advancements in that. So overall, the point is that you remember the BMS started from the just being a cell balancer, that also being outside. Then it went to doing cell balancing while installed on the BMS permanently. Then we started doing safety, and then we started other feature. Over the time, this added features will keep on increasing, and the BMS will keep on getting more powerful, and it will become the powerhouse which will not only ensure the safety, but it will be giving safety, it will be giving features as in customization, and it will do personalization also. Like I have a ether, if I'm driving it, the vehicle should tell me that the battery is good enough for another 40 kilometer, let's say. But let's say other person is driving that same vehicle, and that person is a very aggressive driver, the battery will not actually last 40 kilometer, right? It will probably last only 30 kilometer. So you can do personalization. You can find ways to know the vehicle that who is driving, and then all the information coming out of that can be according to that driver. That is possible, right? So these are the things that we believe will be happening in future. So that's all that I had to share with you. If anyone has any question. Okay, I see a question. Actually, by using NC like software is beneficial over experimental work. Uh, See, you can simulate, it's possible, but that is not generally what is done. Hardware wise simulation will not really give you much of a result. So what is done in simulation environment is the software, and more than that, the algorithms. That is what is being simulated. Otherwise, hardware wise, rest of the things that are going on are actually pretty straightforward. The bigger problem or the more work is on the software side. So majority of work is happening in MATLAB in algorithm development, not much in the simulation of the hardware.
Mr. Misra, this is Dr. Shah. Very inspirational talk regarding battery management systems. I have specific queries regarding your talk. You mentioned that VCU facilities are not up to date in India. So
Yeah.
if you assume that the electric vehicles going to leapfrog within like next couple of years or maybe within a 1 decade, so what do you think India stands right now so that it can manage the EVs which are going to mainly use the lithium-ion batteries in future, and a proper BMS should be in place. So what is your take on this subject?
Okay. See, and I also see a question in the chat box, so I can actually give answer which will answer both of that. See, all these fire incidents that are happening,
And I
like I
also
said,
see a question in the chat box, so I can actually give answer which will answer both of that. See, all these
yeah.
fire incidents that are happening. And I also see a question in the chat box.
Okay, so I see that question, and what our Professor Partha has asked, and this question about fire, they are actually related. See, these fire are happening because of mostly a poor design or a poor manufacturing process. Okay, lithium-ion battery can catch fire, like I said, but making sure that it will not catch fire in 1 million hour of operation is very easy. It's not a very big task. Making sure that there will be no fire incident in a billion hour of operation is very hard. It's not easy today. But making sure that a million hour of operation is actually very easy. But if you see the number of incidents, it's very frequent. So it's not that a lithium-ion battery is susceptible to fire, or it's something that you cannot avoid. You can very easily avoid. Just imagine that all these batteries out there, they don't even have a single temperature sensor. That itself tells you the quality of those batteries out there. And similarly, the manufacturing processes are very poor, like really poor. The type of tests that are done before end of line or before sending out, etc., are nothing is there. All in all, most of the guys are doing is just checking the capacity, if the capacity coming or not. That's all. There is no test for if the temperature sensors are working properly, the type of temperature you are getting, etc., etc. It's not being done. But because of these fire incidents, and especially the one with the major company, the noise is there now, and that noise is has made government start looking into that, and now there are guidelines being developed to ensure the quality of the battery. Many of those current market batteries has gone to ARAI, I think ARAI or ISRO, and there has been reports coming from that they are not happy with the quality of the battery from design and manufacturing at all, right? So this is going to change now. Government has taken note of that. They are getting new guidelines in place, and very soon you will see new guidelines which should not be or will not be possible to be passed by the bad quality batteries that are there right now. It will change, and India need to make that jump. Otherwise, it's not going to scale, because of the fire. A lot of people wants to purchase electric vehicle. They are not purchasing now because not because it is costly. It is costly, but a lot of people are willing to pay that type of money. It's not a very big difference, but people are not purchasing because they're getting scared now. And government has a very ambitious target of putting EV on road. It's not going to happen without taking out that fear. And those actions are being done, and I believe within next few quarter it will be in place. I see AL sensor. I don't understand what is AL. What is AL? Whoever has asked this question. Mr. Priyadarshi Saraswat has asked this question, but I don't understand AL. Sensor and lithium and battery and EV. No, I can't understand that question. Algorithms. Okay. So see, algorithm is the one area where a huge amount of work will be done. I believe that this is one of the most important area, apart from uh, definitely more importance on the safety and maybe addition of some more sensor. But I believe the maximum amount of work will go towards the algorithm development, both for core BMS functionality as well as safety and like I said, the state of charge estimation, the state of health estimation, etc. There will be a lot of work going into that one. Safety probably will take the second seat, and sensors probably will take the third, because those are not that much mandatory or relatively less important than other features. So that is what I believe will happen.
Thank you so much, Mr. Nikhilesh Mishra, for your amazing talk on battery management system. I hope our audience must have enjoyed your talk and learned some technological aspects of BMS. Now I request Professor Partha Saha to present the memento to Mr. Nikhilesh Mishra.
Thank you for your presentation.
Thank you, Professor.
Conclude our session 1. We start with our first talk of session 2 of day 1 by keynote speaker Professor Aninda Bhattacharya from SSU ISC Bangalore on topic titled Beyond Lithium-ion Batteries for Electrification and Sustainability at 3 p.m. Thank you.
Thank you, everyone. Thank you. Bye.